Welcome back to the channel. Today I am going to explain some important questions from previous year GATE exam because the upcoming exam is going to be GATE 2020. So this video would be very helpful for GATE physics aspirants. First of all, if you have not seen my previous video, so please go and watch that because I have explained the concept to find out the term symbol in ground state using Hund's rule. So let's start with this video. The first question is from GATE 2000 and the question is, which of the following is the spectroscopic ground state for Mn3 plus ions of electronic configuration as given predicted by the Hund's rule. Now they have given the electronic configuration to you and they are asking you to find out the ground state using Hund's rule. So in this question you just need to see the subshell which is not completely filled, and that is 3D4, right? All of the subshells are completely filled, so you don't need to check them. You just need to see the outermost shell subshell which is not completely filled. From that only you will get the ground state using the Hund's rule. So as I told you previously also, you need to draw the orbital because it's a d orbital, so it is a 3D4 and you will do the filling of this subshell. So there are 4 electrons. You will fill these 4 electrons like this, and then you will write down the ml values because ml is from minus L to L and L is 2 for D subshell. That means ml values are minus 2, minus 1, 0, 1 and 2, right? Now you can calculate the overall S value, overall L value and overall J value from here. So what would be the S? There are 4 parallel electrons with half spin. That means total S would be half plus half plus half plus half, which is 4 by 2. That is 2. What would be the overall L value? The summation of ML, modulus of summation of ML, which would be minus 2 plus minus 1 plus 0 plus 1. And that will come is equals to 2. And the net J value would be L minus S 2 L plus S, which is going to be 2 minus 2 to 2 plus 2, which is 0, 1, 2, 3, 4. 0 to 4. Now since the orbital is less than half filled, because there are 10 electrons that can completely fill the subshell, the D subshell, but only 4 electrons are there in the outermost subshell. That means the orbit is less than half filled. So the J value of the ground state is going to be the minimum one, that is 0. So the J value is 0. That means the ground state term is going to be, what would be the multiplicity? S is 2, so multiplicity would be 2s plus 1, 2 into 2 plus 1, which is 5. So the term would be 5. And the L value is 2, that means it's going to be 5D and J is 0. 5D0 would be the ground state term. So the answer is option A. The next question, second question is from GATE 2001. The question is that you need to find out the Lande G factor for 3p1 term. Now, because the term is given, that is 3p1, so from this term you can calculate the L value. For P it's 1. S value, the multiplicity is 2s1, which is 3. That means S is going to be 2 minus, sorry, it's 3. So it's going to be 3 minus 1 upon 2. That is 2 by 2 is equals to 1. So S is also 1. What is J? J is given. That is equals to 1. Now the formula for Lande G factor is 1 plus J plus 1 plus SS plus 1 minus LL plus 1 upon 2JJ plus 1. So it is separated by this 1. Okay, this is the formula, and you just need to put the values of L, S and J in the formula and you will get the Lande G factor equals to 3 by 2. So the answer is option B. Okay. Now the third question is from GATE 2004. The question is, the spectral terms for a certain electronic configuration are given. These are the terms. And the term with the lowest energy is to be found. Now in this type of question, you need to know the Hund's rule completely. In my previous video, I have not explained the Hund's rule completely, so let me do that first. According to the Hund's rule, if you want to find out the ground term or the most probable state, then you need to check all the points of Hund's rule. The Hund's rule states that first you need to check the multiplicity. The multiplicity should be maximum for the ground state. The multiplicity should be maximum. Okay, maximum multiplicity. I mean to say that if you are getting any of the term which have the maximum multiplicity, like here we have 5 with the multiplicity, and there is no other term which have 5 or more than 5 multiplicity, that means 5s is going to be the ground state. But if there is any case where the multiplicity is same for 2 or more than 2 terms, then what you will do, you will check the L value. For same multiplicity, the term of maximum L value is going to lie in the lowest state. Okay, so first check multiplicity. If multiplicity is maximum, if you are getting any term of the maximum multiplicity, then that's the answer. If the multiplicity for 2 or more terms are same, then you need to check the L value. For the maximum L value, you will get the ground state term. And if there is a case where multiplicity or the S value and the L value both are going to be same for 2 or more than 2 terms, then you need to check the J value. And as I told you that for the more than half filled subshell, you need to consider the maximum J value, and for less than half filled subshell, you need to consider the minimum J value. Okay. Now if there is any case for which the multiplicity, the L value, both are same, and there is a case where the subshells are filled exactly half. For example, if there is a D subshell and there are 5 electrons, 1, 2, 3, 4 and 5, so it's exactly half. It's not more than half, it's not less than half filled subshell, it's exactly half. That means in this case, what you need to do, you need to consider a term which should be an S term, and the spin should be n upon 2, where n is going to be the maximum number of electrons that can fill the subshell completely. So for the case of D subshell, n is going to be 10. For the case of S subshell, n is going to be 2. For the case of P subshell, n is going to be 6, right? So if any subshell is exactly half filled, then you need to take the S term with the spin n by 2. Okay, now here you know the answer. You just need to check the first point, multiplicity, and you are getting a maximum multiplicity for 5s. So 5s is going to be the ground state term, or 5s is going to lie lowest, I mean with the lowest energy. So option A is the answer. Now the next question, the fourth question, is from GATE 2004. The same question that you did in you did previously. So the Lande G factor, they're asking for 3D 3 term. You can easily calculate S, L, J value, and you can find out the Lande G factor. So in GATE there are lots of question repeats. Okay, so you need to do your preparation like this. I hope this video would be helpful for you for your GATE preparation. If you feel that it's helpful, then you can subscribe the channel. Okay, all right, have a good day.